And in this part of the quiz, we're going to cover questions that include naming compounds with multiple functional groups. So this is a summary of all the rules that we have learned, starting from the alkanes and going all the way to alkenes, alkynes, alcohols, aldehydes, and etc. And to name these compounds that are a little more complex, we need to follow the priority rules for the functional groups. So for this, we need to open this article, which is called How to Name a Compound with Multiple Functional Groups. So the main idea that you need to remember is this. When you determine the highest priority for the functional group, it's going to define the suffix of the compound, which means the ending, the end part of the compound. Everything else is going to be included with a prefix. And this is how you do it. So for example, the carboxylic acid group is going to have the highest priority. And therefore, whenever there is a carboxylic acid group in the compound, the ending of the compound is going to be oic acid. For example, propanoic acid, pentanoic acid, and etc. Everything else then is getting a prefix. So for example, if we have the nitrile groups, we're not going to say it's 5-nitrile pentanoic acid or something like that. We're going to say it's 5-cyano and etc. Just like for the halogens, we're not saying 5-chlorine, we're saying 5-chloro. So that's cyano. That's for the amides and etc. For ketones, it's oxo. For alcohols, it's not all, it's hydroxy. All is the suffix, and that would be the case if we have these functional groups in the compound. So that can be, maybe we have an amine, we have the chlorides, some halides, nitro groups, double bonds, triple bonds, and etc. But as soon as you have a compound that has a higher priority than the alcohol, then it's going to be specified with the prefix hydroxy. So 5-hydroxy and etc. Maybe it's a nitrile, or an aldehyde, or a ketone. And therefore, when we're working on these examples, we're going to have this table open as a reference to determine the priorities of the functional groups. Now let's go to the question and copy it here. And the first thing is you want to identify the functional groups here. One, we have the carboxylic acid right here, and then we have a chloro, so we have a halogen. And we already know that the carboxylic acid is going to be the highest priority. Therefore, the suffix of this compound, the ending, is going to be oic acid. Second, we want to number the parent chain such that gives this functional group the lowest possible number. Therefore, I'm going to start from here. 1, 2, 3. And here we need to choose. Either we're going to go 4, 5, and 6, which allows us to have 1, 2 substituents, so chloro and propyl. While on the other hand, if we go this direction, then we only have 1 substituent. And remember, the idea, the rule is that you need to always have as many substituents as possible, given the parent chain is not changing, the number of the carbons or the functional groups. 5 and 6, so this will be our parent chain. So essentially, this is how the parent chain is going. So this is kind of like the main compound. You can think about this way. Let's say you have a car. So what's most important in this car is the fact that it's a car. Now it's a red car, so you're going to put this as prefixes. So it's a red, I don't know, not pretty, okay, not pretty, and etc. So you're continuing, it's the adjectives. So your substituents are the adjectives. So it's a chloro, propyl, and etc, etc, but it's a carboxylic acid because that's the most important functional group that defines it. Then therefore, what we're going to do is list the substituents alphabetically. So it's C, and we have P. I'm going to put the chloro first. So chloro is on position 5, and therefore it's going to be 5-chloro. Then here we have a propyl, so that's 3-propyl. We have 6 carbons, so therefore that's a hexanoic acid. Hexanoic acid. Again, important part is that the suffix comes from the fact that it's a carboxylic acid functional group. And this corresponds to option B. Let's go ahead to the quiz and check B.